Starting chapter 4, we're dealing with polynomials, and we're addressing one of the California state standards that students need to be adept at operations on polynomials. All operations on polynomials, including long division. So let's start out with some definitions. A constant can be defined as a number. So for example, -5 is a constant, 0 is a constant, 17 is a constant, 3/5 is a constant. A monomial is either a constant or a variable or a product of constants and variables. Remember that product means end result of multiplication. So 3 times x squared times y times z cubed is a monomial. But a constant is also a monomial, so is 2 a monomial, and a variable, so that makes x a monomial also. Coefficient is the constant portion of the monomial. So as we look at the 3x squared yz cubed, 3 would be the coefficient, the constant portion of the monomial. The degree of a variable is the number of times the variable occurs in a particular monomial. So if we have x to the third power, we say that this variable is degree 3 because x occurs 3 times, and we use the shorthand notation of x cubed. All right, let's continue with our vocabulary and look at the degree of a monomial rather than just the degree of a variable. It's the sum of all the degrees of all the variables in the monomial. So if I have 2x y squared z squared, we take all the exponents of the variables in the monomial, and don't forget that there's a 1 here. We don't write x to the first, but it's 1 plus 2 plus 2 more. That tells us the degree of this monomial is 5. Like terms, we learned this in Algebra 1 also. That's monomials that are only different by their numerical coefficients. So for instance, -7x squared y, positive 3x squared y. Both monomials are x squared y. The only difference is the numerical coefficient, 3 or -7. So they are like terms according to our definition. A polynomial then is a monomial. So we can say polynomial when we're really referring to a monomial. Or it's the sum or difference of monomials. And each monomial in the polynomial is considered a term. So 3x to the third plus 2x squared y minus 7xy cubed, that would be considered a polynomial because we have 1, 2, 3 monomials that we are adding or subtracting together. A polynomial is simplified when no two terms are like terms, and we usually arrange them in decreasing degree of one of the variables, and usually in alphabetical order, but not always. So if we have two variables x and y, typically we will say we've got 4xy plus 2x cubed plus 5xy. That's not simplified because we have xy term and another xy term that are like terms. If we say that there's 4 of those xy's plus 5 more of those xy's, which is now 9xy, and then we put them in decreasing powers alphabetically, so x occurs before y, we're going to put the largest x term first, so 2x to the third, and then plus 9x to the first, y to the first. That would be simplified. All right, now that we know what a simplified polynomial is, we're ready to figure out how to find the degree of a polynomial. You look at the degree of each term, of each monomial, and then you take the largest number. So I've got 2x to the fourth minus 3x squared y plus 2x. This term, the degree is 4. This term, the degree is 3. This term, the degree is 1. We take the largest number from the degree of each term, and that's the degree of the whole polynomial. So this polynomial is degree 4. So again, we find the degree of each monomial portion or term of the polynomial, and then we take the largest number. All right, so now that we've got some definitions out of the way, let's start looking at some numerical examples. So let's simplify this polynomial and arrange in descending powers of x, or degrees of x. So as I scan through this, I see that x squared, that's the largest power of x, and 5x squared minus 2x squared leaves me with 3x squared. Then I look for x to the first and find some like terms there. So 1x minus 4x is -3x. Then we run out of variables, so we're down to constants. By the way, the degree of a constant is degree 0, so that would come after degree 2, and then after degree 1. Degree 0 is the constants. I've got a negative 6, and I'm adding a 3 to that. That's negative 3. And there's my polynomial simplified and in descending powers or degrees of x. Let's try another one. X cubed y cubed minus 7xy to the 6th plus x squared y squared plus 3xy to the 6th minus xy to the 6th. As we scan for like terms, and I usually do this in descending powers, there is no other x cubed y cubed. And x cubed is my largest degree of x. So I'm going to write that first. Then I notice that we have some x squared y squared, and that would be my next power of x that I'm looking at, and there are no other x squared y squareds to combine with as like terms, so I'll just jot that down as well. Now I do notice that I have some xy to the 6ths, x to the 1st, y to the 6th, so negative 7 of them plus 3 of them is negative 4 of them, minus 1 more of them is negative 5 of those x, y to the 6th. And we have our polynomial simplified. All like terms that are the same have been simplified and combined and added or subtracted, and it's in descending powers of x. I know y to the 6th is larger than y to the 3rd, but we usually go alphabetical order. So x to the 3rd, x to the 2nd, x to the 1st. All right, here's another one. We're going to add two polynomials, and I'm going to put parentheses around them to kind of signify that they are two separate polynomials. Negative 3x to the 3rd plus 2x minus 4, and I'm adding to that the polynomial 4x to the 3rd plus 3x squared plus 2. So I will look again for like terms and in descending powers, so simplify and put them in the proper order as I go. So here's negative 3x to the 3rd plus 4x to the 3rd. That leaves me with 1x to the 3rd. Then I'll look for x squareds and only see one of them. And I'm adding a 3x squared, so that comes down next. Then I look for x to the 1st, and there's only one of them, so nothing else to add to x to, so I'll bring that down as part of my polynomial next. And after x to the 1st, I'm looking for constants. So negative 4 plus 2, that leaves me with negative 2, and there's my polynomial. Adding two trinomials, and ending up with my polynomial simplified and descending powers of x, x to the 3rd, x to the 2nd, x to the 1st, and then my term with degree 0, just the constants. All right, let's subtract. Now, subtracting is a little bit more difficult than addition, so I'd like to make some suggestions. Now, one of my suggestions is don't subtract. Over the years of watching students subtract polynomials, students will get subtracting polynomials incorrect more often than they get adding polynomials. So instead of subtracting, let's add the opposite of the polynomial we were supposed to be subtracting. So instead of subtracting, I'm going to add, and I'm going to take the opposite of this second polynomial. So again, instead of subtracting, I'm adding the opposite. So that becomes positive x to the 3rd. That becomes minus 5x squared. That becomes plus 8x, and that becomes minus 4. Now we're back to adding polynomials, and I find that students really don't have troubles adding polynomials. So let's look for descending powers. Negative x to the 3rd, positive x to the 3rd, end up to be 0x to the 3rd, so I'm writing nothing down. Let's look for the x squareds that are like terms. 3x squared plus negative 5x squared is negative 2x squared. All right, let's look for our x to the 1st terms. So negative 2x plus 8x is going to give me positive 6x. And after x to the 1st, we're looking for constants. 2 plus negative 4 is negative 2. So again, instead of add or subtracting polynomials, change this into adding the opposite of the signs of every term from that second polynomial, and you are more likely to be successful. So there's our first look at polynomials, some definitions, adding and subtracting, and more of this to come later.